Welcome everybody to day 2 of the MIS safety module training. Yesterday we went through and looked at some of the fundamentals, kind of an introduction to the module, what it is, how you mount it, the fact that there are two different ones, two different versions, and just kind of a getting started. Well, today the rubber's going to hit the road, so to speak. I'm going to be using the module today with Connect software. So today I'm going to be covering Connect software safety setup editor. Again, I should have chosen the correct term. I'm going to further attempt to define some of the many acronyms that are used in the software to kind of give you a feel for what they mean and what it is, what they are. And then we're going to look at the example that I put together. So once again today, we are joined by Mr. Mike Durden. And for those who weren't here yesterday, Mike is a senior field application engineer that works out of our central region. And Mike has had experience applying this in the field. So I thank Mike. He's been very instrumental in providing me with help getting this going. So let's get started. So the Connect Software Safety Editor. So the safety module is found, or the dashboard for the safety module is found in Connect Software, as you can see here. And this is where all of the programming of the MIS 250 or 210 module is done right here directly in Connect. So as you can see in the screen grab there, we have safety setup, import, export, and some other tools. And like everything else in Connect, when I'm online, this screen will look different than it does right now. The safety application must be created offline and then downloaded. Once again, it's not really a black box as I think of a black box, but it can kind of be thought of that way, I suppose. You're going to be creating the application, you're going to be testing it, and then once it's downloaded, well, it's there, and it's not meant to be accessed or adjusted. I mean, the safety setup is not meant to be accessed or adjusted once it is in go mode that you see here. So the workflow now, and I touched on this a little bit yesterday, you're going to use Connect to create a new project as you would normally, assign an IP address to the drive that you're using, upload the configuration into Connect, enter the motor details and the motor feedback details, perform an auto tune. Then we will develop the safety application. So once the application has been created, then we're going to enter into test mode. And there is safety test mode that I'm going to be working with today. Once you've decided that your safety setup is performing to your specifications, then you're going to download and start the safety application. And I'm going to leave mine in test mode today, but I will be showing you how to click the download and go buttons. So that's kind of the flow here. And again, I want to emphasize, this is an add-on module. It's not unlike, in terms of workflow, it's not unlike an MCI module in the sense that it's got its own configuration that sits outside of the basic drive configuration. So start with the basic and then come in and do the MIS module. And I will also point out for those of you who are doing network safety or you want to see network safety, I'm going to be creating some YouTube videos for those specific applications in the near future. So to create a new safety setup, you begin by clicking on the safety setup icon from the MiS dashboard that you see here. So I would click on the safety setup over here. And here is what the user interface for the safety editor looks like. You can see it's a tabbed setup, and it's designed to flow from left to right, but you can jump around in here to any part of the setup that you would like to edit. So the tabs are network, encoders, system, functions, inputs, outputs, and scope. So we begin on the network tab. So the safety modules support two different network protocols: CIP safety, which is for Allen Bradley PLCs, and FSOE for Beckhoff EtherCAT PLCs. And once again, I'm not going to be using a network interface today. So in the interim, and before I get my YouTube videos started, you're going to want to look at section 8.3 of the MiS 210 Safety Module Installation and Operating Guide for details on how to use this network interface. So as you can see, I have ticked none here. So that's the first part of my application. Now I'm going to be flipping back and forth between the slideshow and Connect as we go along, but since I'm not really doing anything on this page, I'm just going to leave it like that. Now, the Encoders tab. So we look at the Encoders tab that you see here. This is where you're going to enter details regarding the primary and secondary, if you have one, encoders being used as part of your setup. As I mentioned yesterday, there is a distinct advantage to using a motor with an NDAT 2.2 protocol feedback device. And the reason for that is the fact that I am able, instead of having to add a sort of secondary safety encoder, I can use the motor encoder. I can do what's called snooping. So the safety setup here is going to be able to read the speed and position of my primary encoder because of the fact that it's an NDAT 2.2 protocol. NDAT 2.1 is not supported for this feature. So, again, the easiest thing to do, in my opinion anyway, is to just choose your primary motor and include this NDAT 2.2 protocol on that motor. Now, if you've got, a big drive with a closed loop vector mode, or what I should say is RFC-S mode with feedback, then you're going to need to pay attention to the primary and secondary encoders and enter your parameters accordingly. So I'm going to flip over to Connect now and show you what I've got going on. So here's my safety setup, none, and then encoders. So the first thing I did, primary encoder selection, I just chose drive P1 feedback. And this auto-populated. It knew that it was an NDAT 2.2, so it basically, everything that's ghosted or grayed out here was just sort of automatically detected by Connect software. Now, what's different, and I am going to touch on this in a minute, is the fact that the encoder input is treated differently than we would normally do with an encoder being disconnected to the drive. So specifically, let me flip back here. Specifically, what I'm talking about is that with our drives normally, there are 3 parameters in menu 3 that are used to form a normalized encoder position. That is not the case with the safety module. Encoder feedback is in units of counts. Now, as you can see here, I can create user units from those counts, but it is not a function of our normal, well, that's a bad choice of words. It is not relative to the normalized encoder position that we normally look at. And as an example of that, how you would use this is my encoder has 19 bits of resolution that you can see right there. Therefore, the way you interpret the number of counts per revolution is by exponentation. So using my encoder as an example, if I raise 2 to the 19th power, because I have 19 bits here, I end up with 524,288 counts per revolution. That is absolutely critical for a lot of what we're going to be doing going forward. Now, I did not elect to use user units as part of my configuration. But if I had, well, let me just flip over. If I wanted to do that, I could tick this. I could say, I don't know, it's rotary, so I could say it's degrees. And then I'll say DEG. And I'll say there are 360 degrees per 524288 counts. So now I have converted my encoder units into user units. I don't wish to do that for my application, but just so you can see that that's what you would do. You're also able to monitor the encoder supply voltage if you would like. So you would choose the supply voltage that you're using. And if there's an external supply voltage for the encoder, so in other words, if we're not using our internal drive power supply for the encoder, you can also choose an external supply here. Then you can do, this is kind of nice too, speed averaging, so that this data or this value for your speed isn't bouncing all over and really granular. You can just apply a averaging sample to kind of, provide a more stable feedback for your encoder speed, if you should choose to use that as part of your application. Now, if I had a secondary encoder, I would use it here. It says not in use. Well, okay. So if I had one and it was connected to drive P2, I would choose that, or the safety the encoder connector on the safety module. So if I had one there, secondary device type, I would just choose it, and so on and so forth. But in my application, and again, by virtue of the fact that I'm using an NDAT 2.2, I don't need this secondary encoder channel. So that's the encoders tab. Now, before we get into the functions and sort of the heart of building a safety setup, it's important that you look at these acronyms. And honestly, the best resource I found for decoding what these things are is literally in the manual. As you can see, section 8. If you look at the section 8 bookmark in the manual, well, it tells you right there, SS is safe stop, and some of these get to be pretty interesting. Snore, for example, safe not or. So SOAR, SDI, SNAND, there's a good one, safe not and. So, and then down here, we get into some of the safety functions too, or the MSFs also. So these acronyms here are best found in the manual, right? So specifically the installation and operating guide. All right. So one thing I do want to point out, though, these kind of are, these we're going to be using quite a bit. So your safe network input in your safe network output, we're not using those, but what I'm looking at is safe Boolean hardware outputs, SHOS. There are two of those on the module. I'm going to be using one of those. And then safe Boolean hardware inputs, which SHIS. There are 4 of those on the module, and I'm going to be using 2 of them in today's example. So there's a boatload of these acronyms, and you're probably best looking at these so you understand what they're talking about going forward. So now if I go to the System tab, all right, the System tab is used to configure the reset, position, and speed and alarms that originate from the MiS module. Most importantly, in terms of my example today, is the reset. There are 2 resets. There's a system reset and then a peripheral reset. The system reset is to clear any safety module alarms, and the peripheral reset is to reset any remote devices, such as a secondary encoder. So let's go look at my example now, and I'll show you how I have mine set up. So on the System tab, the system reset source, all right? Now this BIS, all right? So if I drop that down, that is a non-safe Boolean input. Now that sounds fine and dandy, but what does that mean? A non-safe Boolean input is found in the setup menu for the module, starting with parameter 51. And I think I talk about that here. By golly, I do. So non-safe Boolean inputs are taken from the host drive's application menu, right? And now in the documentation for the safety module, that's referred to as the setup menu. So if I'm using an MiS 210 with an M700, that would be menu 17, right? So here in menu 17, you see 4 non-safe Boolean inputs. And these are just bits, okay? Now today, and with my example, I'm using a Digitax HD, so that is menu 16. Now these bits are taken as a 4-bit nibble to produce a single state output here, right? So in my example today, I'm using menu 16. So let's go back to connect now. So I'm using non-safe bit 1 value. And the setup menu is menu 16. So let's look at that. As you can see, it's MiS 250 setup. There it is. So here are all of the parameters that are dedicated to the safety module. And as always, anything in non-bold font is read-only, right? So these things are read-only. Now, down here, on the other hand, here are my non-safe inputs. So BIS bit 1 is 1631. BIS bit 2 is 1632. So if I go back to my safety setup now, you'll see right there. My system is BIS bit 1 value. Well, that's menu 16, parameter 31. And BIS bit 2 value is menu 16, parameter 32. So that's how I have both of my resets configured. This, I can't imagine why. It's a safety module. I don't know why they've provided an auto reset. You know, generally, when you have a safety system in place, it's very manual and purposely done that way, so that you must physically actuate the reset in order to reset the safety circuit. But if you want it to auto reset, you would tick them. System start reset, you could tick that as well. Now, what I did for my example here today is I set up a custom list. Now, my custom list, I've got my drive, my example drive here. I've got that set up in preset speed mode. And then I just added my 2 resets so that when I'm in testing mode, I can actuate the resets from the custom list, and I can also adjust the speed using menu 1 parameter 21. So when I actually get to demonstrating my example, I'll be running it, so to speak, from the custom list that you see here. So, and you're going to see this when I get it started. The first thing you must do is once it's downloaded and once you start testing or you push the go button, you must reset it first in order for it to operate. So, and I'll go through that once I show you live what I'm doing. So, non-safe Boolean inputs. Now the functions. A safety setup is built, not built using a combination of motion safety function, MSFs. So once again, just like we looked at the acronyms for the inputs, outputs, and network stuff, here are the safety function acronyms that we're going to be exploring and using to build our safety application. So the safety application consists of safety functions, logical operators, inputs, and outputs. So these functions are documented in section 8 of the installation and operation guide. So that's a very handy resource. A machine safety function, MSF, can be thought of as a function block in the sense that it has input, at least one input, and at least one output. Now, in compliance with the international standards, the language that's chosen here is not inputs and outputs. Inputs are referred to as a source. So as you can see, here's a graphical example of an SLS, safe limited speed, machine safety function. So over here, we have inputs that the user can actuate and affect. So there are inputs, but the outputs now, even though they're labeled out, they're actually referred to as demand right here, right? So the demand out. Now my example today, I am not cascading safety functions, which can be done. So if I were to cascade this function, I would use its demand out as the input to whatever the downstream safety function is. So I might cascade safe limited speed into a safe stop, for example. But in my application, I'm not doing that today. Now later on, I'm going to show you another important thing, and that is once the safety setup is put into run mode for real, unless you have provided access to these things by assigning them to the setup menu, you won't be able to monitor or access them. So I'm going to show you how to map some of these things to the non-safe outputs in the setup menu, so you can at least check to see what's going on inside the safety module. Because again, I don't want to use the term black box, but for all intents and purposes, that's pretty much what it is. Another important thing is when you're chaining or cascading these functions, you can chain them together so long as you don't tick the alarm output. Once an alarm is raised, then that's the end of the story. it won't proceed to the next cascaded safety function. So I'll show you that live now. So here's my safety setup. And now we're talking about the functions. So here they are. So in my safety setup, I have safe limited speed. I have safe emergency stop. And then I'm using a logical AND as part of my example. Now what I was just referring to is this. If I were cascading these things together, and I mistakenly, ticked that, for example, safe limited speed, if I were to cascade that into a safe stop, right, I would not tick generate alarm on my safe limited speed, because that would prevent me from flowing into my safe stop. I'll probably do another more elaborate example at some other point, but I purposely wanted to keep this one as simple as possible just so you could get a feel for how this stuff goes together. Does anybody have any questions? Sean, does that make any sense? All right. So, safety functions. Right? Now, in this example, what I'm showing today is a safe emergency stop and safe limited speed. So this setup is designed to mimic a scenario in which a machine operator has an e-stop push button that, when it's active, will stop the motor and open the safe torque off contact on the Digitax HD. In addition to the e-stop push button, the machine operator will also be required to enter into a safety guarded area. So you can envision a web of some sort for the purpose of threading the machine, right? So in that scenario, once he enters into the guarded area, as indicated by the state of a safe input, the motor speed will never be allowed to exceed 60 RPM in my example. And I'll show you how that works. All right, so to add machine safety functions to a setup, you simply click on the one you want to use, and there'll be a little plus icon that appears to add it to the setup. The order in which you arrange these doesn't really matter, but I suppose if I were cascading things together, I would probably organize them from left to right. But it really doesn't matter. It all comes down to how you have them actually configured. So the first thing I'll look at in terms of machine safety functions is safe limited speed. Right, so SLS. Now you see the _1. As I alluded to yesterday, or as I showed you yesterday, you can have multiple instances of some of these safety functions. So the 1 indicates that this is instance 1 of safe limited speed. Same token here, I used a logical AND. Well, that's instance 1 of my logical AND. There can only be 1 instance of a safe emergency stop, so that's why it does not appear there. So when I say safe limited speed, limiting means that it will prevent the current motor speed from being increased beyond what is chosen for the speed limit, right? So what I did was I assigned the speed limit command source. This is the input. Source, input, demand, output. I'm using safe input 2 on the MIS module, the safety module, as the source to trigger this function. Now, I did not do anything with 0 command speed or speed underride. Both of those are disabled. The output of this safety function is one of the channels which I am feeding into my AND function. Now, again, safe limited speed. So what this does is it's going to stop the motor if the safe limited speed is true. All right? Excuse me. So it's going to stop the motor once the speed exceeds the speed limit. And it's going to do so immediately. The speed limit is in counts per second. Now, in my case, I am going to speculate that had I used my user units, it would have been in degrees per second. But here's that number. So this is 1 rev per second, which equates to 60 RPM. So if while the operator is within the guarded area, the PLC attempts to raise the speed beyond the speed limit, and I'll demonstrate this, the motor will stop immediately and the safe torque off will open. Now, I've not experimented with rate or time, but the end result is if this speed limit is exceeded while this block is active, then it's going to stop the motor immediately and open the safe torque off. Now, if the motor's already running faster than this speed, no limit will be applied. And that's an important distinction. It says safe limited speed, but it is not a overall speed limit, right? So there'll be a host controller of some, most of these applications will have some PLC or another source that's controlling the motor speed. So, when the operator puts the machine into thread mode, for example, the PLC would drop the speed below this limit, right, all the time while the operator is within the guarded zone. So this is not an overall speed limit. This is a speed monitor while the source is active. If you want a speed limit, you would have used SSM, Safe Speed Monitor, to actually limit the motor speed to your desired value. But this one is just while that's active, the motor cannot run faster, and in my case, of 60 RPM. And I did not elect to turn on an alarm if this function is activated. And the reset source is my system or my 1631. That's my non-safe Boolean input that I'm using to reset the system. So let's look at that in Connect. There it is. So it's the same thing, right? So 0 speed command source, this controls whether the function monitors for 0 speed or not. Speed underride, safe integer input selector whose input allows safe speed to be reduced dynamically. Now over here on the outputs, right? This is one channel. This is one of my AND. The other one is my safe emergency stop. So the demand or the output goes to the second input of my AND function. But notice this. I have also set this up to be used as the source for that is a non-safe output. So that is again in menu 16. So this is one way of creating and providing a diagnostic resource once the safety application has been downloaded and put into sign off or go mode. That's really important. Otherwise, you'll have no way of knowing whether or not this particular MSF is active. So I'm going to be showing you that here in a little bit when we actually run this thing. So that's my safe limited speed that I'm using in this example. Safe emergency stop. The safe emergency stop MSF will simply open the safe torque off on the drive whenever its source is active. So in my case, safe input 1 pair on the MIS module is being used as my safety emergency stop. And the demand, as I mentioned, is the second or the first input to my AND. So I'm ANDing this and this together to produce an output. And again, the resource, or the reset, is my system 1631. No, I don't want it to automatically reset or start reset. So that's my safe emergency stop. Then there's safe limited speed. The last thing I do in my example today is I'm using the logical AND machine safety function. So here, it's a 2-channel AND. This and this must be true to produce this. Now, the demand, and this is kind of subtle, this is one of the 2 safe outputs on the module. Now, and I'll show you my demo here in a little bit, but this output on my MIS 250, it's what's wired to the safe torque off contact on the drive IO connector, right? So, and again, the whole point of this MIS module is to control the safe torque off. That's what we're doing. So if either demand is not true, the safe torque off on my drive will open. So next, let's look at the inputs. This is the hardware inputs on the module, right? Now, as it turns out, it's oriented just like I need it to be for my MIS 250. It's vertically like this. So you have safe output 1 on terminal 8. That's what I'm using today. You have safe input 1B and 1A. Again, these are pairs. And you'll notice here that safe input 1A has a filter time of 1 millisecond in this example. The discrepancy time, right? That, and again, because 1A and 1B are treated as a redundant pair, if those 2 don't close within, in my example, 1 second or 1,000 milliseconds, that will generate an alarm. The mode now, I talked about this yesterday. I'm not using the pulsed output to power the safe input. I'm using, in fact, the 24-volt power supply on the Digitex HD I/O connector to power my safe emergency stop input. So external control power supply. If I were using the pulsed, it would say pulsed continuous power, or pulse power supply, or something to that effect. But here is what I'm connecting to these 2 inputs. So one of those is my safe emergency stop. The other one will activate my safe limited speed. So that's hopefully pretty straightforward. It's a nice graphical picture of how the inputs on the module are organized. Down here, here's my other pair. Safe input 3A, I'm not using. Safe input 4A and B, I'm not using. So there are 4 pairs of safe inputs on the module, 2 pulsed outputs, and 2 safe outputs, terminal 8 and terminal 14. Now, the hardware input reset, to reset this will be, once again, my non-safe setup input 1, which is menu 16, parameter 31. So that's how I have the inputs organized for my example today. A little later, after I show you how this works, I'm going to show you the non-safe inputs tab. That's where you map the things that you want to look at after it's put in go mode to non-safe inputs and outputs. So I'll be showing you that here in a little bit. But this is the input screen on the safety setup. Right, so I touched on this yesterday. So were I to use the pulsed outputs to supply power, this is what I would have done. I could have wired the output of terminal 7 to one side of my switch and the output of terminal 1 to the one side of my other switch to designate that when both switches are closed, I'm in maintenance mode. So let's go back and look at that. Terminal 2 and 3. Terminal 2 and 3, those are my inputs to safe input 1A and 2A. But then the power would come from terminal 7 and 1, which are pulsed output 1 and pulsed output 2. That's actually probably a better idea, just because of the additional checking that's performed. Again, these inputs are normally open, so there would indicate that the machine is in what's called maintenance mode. Right, when it's open, it's active. When it's closed, it's not active. So that is actually kind of a better way of doing things. Now, what you don't see in this diagram is you need the other pair here too. You need the complements here in order to get this to work. So that's a good idea. Those pulsed outputs are probably the way to go. Right, let me flip back to my application here and connect. So we've looked at the safety functions that I'm using and safe emergency stop, safe limited speed. Here's the inputs, right? So, you just use the drop-down list to assign the connections as you see fit. And here I have mapped my non-safe outputs right here. So again, what's that used for? That is used for once it's put into go mode, I want to be able to see if the input is true. And the only way I can do that is by looking at one of the inputs in the setup menu, which in my case is 16. Right? So there's my inputs. Now we're going to look at the outputs. Well, actually, I skipped that. I went right to the scope tab, which I should not have done. So the outputs tab right here looks like this. So the source for the output is my AND. So in output 1 is used as my safe torque off to the drive, right? So if I go look at my functions and my AND, you'll see that when both of those are true, I get my safe output 1. I'm steering that to safe output 1. And that, again, the demand is the output from that block. So that is what's shown here. Now I'm not using either of these features here, but that just shows that that's terminal 8. I'm not using my second safe output at all, terminal 14. So that's just unassigned altogether. Now what's going to happen, you'll notice as you're using this tool, if you make a mistake or you don't connect something correctly, you'll see warnings down here. There'll be an X that appears in a triangle. That designates that something is not right. So I'll see if I can create an X just to show you. Yeah, see that? Nope, can't do that. So that's nice too. It looks after what you're doing to make sure that you're not making any mistakes. Right? So that's what you want to see. I don't want to see any of those triangles appear on any of my functions anywhere. So that's outputs. Let's take our 10-minute break right now, and I will resume again at 11 o'clock. Does anybody have any questions? Okay, then we will pick up again at 11. All right, welcome back. I'd left off talking about the Outputs tab of the safety setup, in which you set up your safety outputs. And the tab that you see here is the Scope tab. Now what the Scope tab is used for, it's used in conjunction with Connect Software's built-in software oscilloscope. So for those who have not seen that, let me go back to Connect, and I'll go back to the dashboard here for the drive. And in Diagnostics, you'll see onboard scope. So Connect has an onboard oscilloscope, not the same as our CT scope product, but this works very similarly. So when I am looking at the Scope tab, what I'm looking at is assigning safety setup functions that you would like to observe or record using the scope to any one of those 4 sources. Now I did assign a few of my safety outputs to the scope just as an example. So the Scope tab is another way, between the scope and the non-safe outputs that I'm going to demonstrate. Those are the only 2 ways that you can sort of peer inside of the safety module to see what's going on in there once you download and sign off on your safety setup. So let's do that now. So once I've got my safety setup configured, the next step is to download it. So I'm going to go ahead and show you what that does now. So here I am with Connect, and I will go to the MiS dashboard. Now I am offline right now. So I'll go online with my demo. Now I'm able to download it. Now this is not the same download process that if I were just downloading parameters to the drive. And you'll see what I mean here in a moment. So it says download will replace the current module configuration. Do you want to continue? Sure. Now it performs this validation. And not only that, and yesterday I touched on this, you're required to set up a username and password in order to access the safety module. So I'll enter my password like so, and then log in. Now, once it's done downloading, it does a check. I think it's like a loop back. You'll see that it downloaded, it performed this calculations on the parameters for the functions, and now it's uploading to compare the two. So you see it's verifying. If everything checks out, like it apparently does here, so the green check, we're good to go. So what I want to do now is I want to test my application. Testing it is not the same as running it. Literally, we're testing. So I'll enter into test mode now. Motion safety functions will run and drive output may be energized. Now, this testing, you can have set a limit. Well, I left it wide open, which means I can run test mode for up to 24 days. If that's not sufficient, I can further reduce the test time there, but I need all the time possible, so I'm just going to leave it that way. So now I'm going to enter into test mode. And here is what we get. This is actually quite nice. Before I even explain what this stuff is, I want to go back to the dashboard for a moment. And specifically, once I'm online, this information and status is really important. Because what it says right now, the safe torque off is active, which means the drive will not turn the motor. I have no alarms. I am in configure mode. There are no faults, right? So that is very helpful information. So now I'll go back to my testing. So the testing is organized here. Inputs, system, safe limited speed. These are the 2 or 3 motion safety functions that I have elected to use as my setup. And then outputs. So here are my inputs. Now I'm going to switch view here and show you my demo. So there's my demo, and all I've done is I've built this little test box here with switches for my 4 pairs of safety inputs. So that's what I'm going to be using to run my demo. Now I'm sorry for moving the camera around, but I'll move it up here so you can see the wiring. So that's my safety module wiring right there that's connected to that switch box. And you see the yellow wire, that's the safe output that is connected to the safe torque off contact on the demo stand. Right, so I'll zoom in a little bit so you can see that. All right, I guess I won't. That's what we'll leave. So that's my demo. Now, what I'm going to do is I'm going to look at system. You can see the status of input 1 and input 2. I'll go ahead and trip my e-stop just so you can see it coming on and off. See that? Safe input 1 is my e-stop, so now it's false. If I turn it back on again, now it's true. So my system, if I look here, it says that it's waiting for a reset here. So I'm going to go to my custom list now, and I'm going to do my system reset. And my peripheral reset. There we go. So now you can see my motor is running. Well, again, it's in preset speed mode. I have my run switch true, so that's why my motor's running. And it's running at a speed of 200 RPM, right? So now what I'll do is I will go back to my setup, my testing, and look at the inputs. So the first thing I'll do is I'll just test my safe emergency stop. Right? So the demand is true right now, and the source is true. Therefore, my drive is energized. So to test this, I'll just flip my switches now. Boom. So now they're false, which means they're active. The drive will not turn the motor. So the motor stopped as advertised, and it will not turn the motor. Now I'll turn my safety switches back on again. The drive did not enable. The safe torque off is still active. It will not turn the motor. And the reason for that is that I need to physically reset it in order to run it. So I'll come up to my custom list, and I'll toggle my reset bit. There we go. My motor's running. Now, to simulate the scenario for the safe limited speed, I'm already in excess of my limit. So if I were to enter into the guarded zone right now, given my configuration, the safe limited speed function would not activate. So I'm going to reduce this speed to something less than my limit, which is 60 RPM. So there you can see the motor has slowed down. And now I can test my safe limited speed, which is right here. So to test my safe limited speed, I'm going to turn it on. I'm going to simulate the operator. The operator is now in the guarded area. So the demand for this is now true. The demand from this function is now true. So now the drive is looking at the speed that I have configured as a limit. And because I'm within that limit, 50 RPM, this function is true. It's not, I'm still spinning the motor. But watch what happens now when I go back and I try to exceed 60 RPM, which is my limit. I'll make it 70. Boom. The motor comes to a standstill. So that is the extent of my demo. Safe limited speed is active. Now, if I go and reset my switches, I'll turn my guard switches on again. Once again, the safe torque off is still active. It will not turn the motor because it is waiting for me to reset. So I'll come in here, and there we go. We're reset again. Now, I don't have any peripheral devices to reset, so I really wouldn't need to have used this, but it's just there. So that's my demo, all right? And what I want to show you now is these non-safe outputs that I'm going to be looking at. So that's in menu 16. Well, actually, let me go back and let me go offline here, and I'll show you my setup. So I'm going to go offline, back to my safety setup. And now what I want to do is look at these non-safe outputs. So what I've done is on the non-safe outputs, there's my two safe inputs. I want to see what the state of those are once I've signed off on the application. I want to see what those two are. And I also want to see the demand and the demand output from my two safety functions. So these bits will appear starting with menu 16, parameter 31, 2, 3, and 4. So I'm going to go back online now. I've already mapped them and downloaded it. So now, oh, and that's the other thing too. I should, gosh. Do not forget, and I should have pointed this a long time ago, when you're making changes, just like anything else offline in Connect, you need to click Save to Project, because I'm not connected to the drive when I'm doing my safety setup. So as you're going through here and you're making changes, you want to make sure that you save those to the project for each step before you download. Right? So let me go back to menu 16 now, and here are my bits that I have mapped. These are the non-safe inputs. So let me go online. Oh, I'm sorry, it's not, I'm sorry, not 31, it's 51. Or you know what? Yeah. Those are inputs. Yeah. These are non-safe inputs here. These are non-safe outputs. That's my scope right there. So non-safe inputs, non-safe outputs. Let me go back to my dashboard again. Safety testing. There we go. So I'm back in here again. So right now my inputs are true. I'll turn them off. Let's go look at menu 16. Yeah. Sorry. Outputs, non-safe outputs. I didn't mean to be confusing there. I have mapped non-safe outputs in my project. So as you can see, I just turned off 2 of them. So if I turn the other 2 off too, they're off now. So let me turn them back on again. There we are. And now I'll go in and reset my safety setup. And we're good to go. So these non-safe inputs and outputs and the scope are very useful when it comes to testing, or actually not testing, when it comes to seeing the state or status of your safety module once you put it into run mode. So all that remains now is for me to do exactly that. If I'm happy with how this is working, my next step would be to come to the dashboard. I would go online. I'm still in test mode, so I will stop it. It's going to ask for my password. Now this is important too. This round trip code. To ensure you're connected to the correct drive, you need to read the round trip code, which is a parameter 1612, on the drive keypad, and that's critical. You might think, well, all right, I'll just go in here. Well, it won't let me off there. So I can't read 1612. If I had a keypad, I could. So to satisfy this round trip code, I need to enter the drive serial number, right? Because I don't have a keypad on my drive. So my serial number is, let's see, what was it? 8677. Is that correct? Let me look. I had this memorized because I've done this a few times. 894. Okay, that's right. All right, so it's 89467733030. That's the serial number from the sticker on my drive. Verify. Stop. Okay. Safe torque off went off. Right? You don't hear that anymore. So if I were satisfied with this now, I would choose download. Yes. Same thing as before. It's checking the configuration. It's going to do this validation now. Now, I'm not going to enter into test mode now. I'm satisfied with it. So if I want this to be permanent, I'll sign off on it. So this will put the safety module in operating mode. It'll change it from test to operate. Right? So to continue, you must declare that you have tested the configuration and are satisfied that the operation is as specified. Documentation detailing your configuration will be written to your project and can be viewed and printed using the viewer in the help section. So the last step would be to sign off. All right, so here's the safety report. So let's look at that. So this is the safety report in PDF form. It just details what the safety setup is. So that's very handy. So confirm that you have tested and signed off the configuration and want to put the safety module into operating mode. Okay. Now it's in operating mode, right? So now it's operating, it's executing. Notice here, I don't see my nice little testing dashboard, and this is what I'm referring to. It's running now. So I have to use my menu 16 parameters or the scope to see what's going on inside. Now some of these other things, the Systema, this is a German organization, safety organization that's part of TUV. And they have, if I click on that, does not appear to be installed. Yeah. So this is software that is used as part of the safety analysis. And it's quite involved. But so I'm not really interested in that, but if you were to do this, and I think if you were to ship it to a European user, you would need to use those. But that's all I have. That's my safety setup. That is the MiS safety module. Does anybody have any questions for me? Mike, do you have anything to add?
A couple things. One, I want to point out that those items that were mapped in menu 16 could be actually be tied to, like say the non-safe input ones in menu 16 could be tied to drive inputs or module inputs or an HMI. And same with the non-safe outputs. They could be tied to a physical output or they could be tied to an HMI in a real life application. And then one other thing is when you do configure those scope values, there's 4 of them.
Mm-hmm.
You don't even have to scope. It actually lets you look at any variable within the module. And that'll be in menu 16 also. So if you were to look at menu 16 right now, Pete, you'll see down at the bottom, there's parameters dedicated for the scope.
Yep.
So see them right down, yeah, right there.
Parameter 90.
Yep. So you could even just use those to look at variables or use even CT scope or the onboard scope.
Yep, which I'm looking at here.
Yep. Great job.
Yeah, and I'm going to repeat what Mike said just in case it didn't come through the speaker very well there. But Mike makes a good point when he's talking about these non-safe inputs and outputs up here that I've been using or that I mapped. These can be mapped to HMI inputs or HMI buttons and physical inputs and outputs on the drive as well. So thank you for pointing that out, Mike. Anybody else? Anybody else have any further questions? All right. Well, thank you for attending. Thank you for using Control Techniques products, and we'll see you next time.